Hello students, I'm Dr. Tanmoy Biswas. I welcome you all in my channel, TanmoyChem and Facebook page, Chemistry, the Mystery of Molecules. Today's topic of discussion is a very interesting topic, this MCQ. By the way, this is, I believe, very easy topic. That's why I expect everyone, please pause the video, try by yourself, and whatever answer you know, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now, what is the major product of these reactions? There's an alkene, HCl peroxide, NaOEt, and heat. So this is actually two kind of reaction. One is addition reaction, another is elimination reaction. But before going to the main discussion, let's learn a little bit about them. The peroxide effect. Now, this peroxide effect is observed during the addition reaction of unsymmetrical alkene and unsymmetrical addendum. I guess we have studied this during the study of Markovnikov's rule. But this peroxide effect is only observed for HBr, not for HCl. So you do not expect that, sir, this peroxide effect or anti-Markovnikov addition you may have HCl. No, it will be simple Markovnikov's addition. Okay. So I guess you know the rule, negative part of the addendum will get attached to that carbon which is poorer in hydrogen. Okay. Obviously, during the addition of unsymmetrical alkene and unsymmetrical addendum. Now, next, HCl does not show peroxide effect as the HCl bond energy is quite higher. And third point, the elimination. It follows Set-Zep rule. So, Set-Zep rule result more substituted alkene as major product, and look at the question they have asked for major product. The transition state for this elimination have lower energy of activation. Now, when some process have lower energy of activation, the rate of that reaction increases and eventually it results the major product. Now here more substituted alkene is more stable because of higher number of hyperconjugation. These higher number of hyperconjugation result larger extent of delocalization of electron, and higher the delocalization of electron, obviously higher will be the stabilization. So this is the overall concept for this problem. Let's look at the mechanism or how this reaction is happening. See, this is an alkene. Pi electrons are loosely bound to the nucleus. So you can expect, sir, this HCl which produces H plus. By the way, HCl is actually polar protic molecule. So it releases this H plus, and that H plus will be added to the double bond. Now here also we shall get major product, means obviously first step it will produce a secondary carbocation, and second step this chlorine minus the counter anion will go and attack there to produce the product of the first step, that is 2-chlorobutane. Next step, it react with NaOEt heat. So it's an elimination reaction, means sodium ethoxide will act as base. Now there are two options you may think. This side beta hydrogen, this is also beta hydrogen. So which one should be abstracted? Now in this case, the Set-Zep rule comes. It says more stable alkene should be the major product. So obviously it will abstract this proton and ultimately this will come out. I mean E2 pathway. So it will result more stable alkene, this one. So this is the right answer, or 2-butene. Now what is the right answer? Option C is the right answer. Now if you get such kind of problem in your exam, how to address them? First you need to remember that HCl doesn't show peroxide effect. So the addition of HCl across the pi bond will follow the Markovnikov's rule. I suggest you, if you cannot get the right answer directly, please write step by step. Second thing, sodium ethoxide and heat, major product. So this is actually elimination reaction. So obviously it will result more substituted alkene. Now you may have little bit doubt that, sir, is ether formation possible? See, it is less likely, and question asks major product. So we should focus on elimination, not nucleophilic substitution. So here, this is another thing. Remember one thing, heating prefers elimination over nucleophilic substitution, because in case of elimination from one molecule I get two molecules, so that's why entropically that is favorable, means entropy positive, and we know this delta G expression is equal to delta H minus T delta S. So delta S more positive, temperature higher, so obviously this part T delta S will contribute more towards the negative value because it is already having a negative sign. And if the delta G is more negative, more will be the spontaneity of the process, means that will be more favored. So that's why I am saying, while you are heating along with sodium ethoxide, the elimination will be preferred here. And second thing, this halide is also secondary. Secondary halide doesn't show that much efficient nucleophilic substitution, I mean SN2 type reaction. So obviously, this case elimination will be preferred. Now, this is the overall discussion. I believe this video may be useful. Thanks for watching.